Please like and subscribe to this channel and press the bell icon to get new video updates.
Hello, this is Hugo Leuteritz and the radios and direction finding of Pan American Airways for the Antique Wireless Museum YouTube channel. We're going to talk about Pan Am radio equipment used through World War II. Most of this equipment was designed and built in-house from scratch. Other commercial pieces were modified in-house for Pan Am's needs. We're also going to talk about the related Pan Am Airways high-frequency direction finding systems that they used, and also introduce Hugo Leuteritz, Ferris Sullinger, and Pamsco. 2 days after Amelia Earhart and Fred Noonan went missing, three of the Pan Am high-frequency direction finders heard and took bearings on weak, wobbly, poorly modulated AM signals, and which the bearings pointed back toward the vicinity of Gardner Island. I've always wanted to know what equipment was actually used by Pan Am for this. That took me to the Pan Am archives at the University of Miami, where the best item found was this photo album of Pan American Airways radio installations across the Pacific, 1936 through 1941, and a number of pictures from that album are used in this presentation. In the PBS three-part series Across the Pacific, which deals with the early days of Pan Am, one of the stars is Hugo Leuteritz, radio engineer. The Leuteritz archives are at the New England Air Museum in Connecticut, and so some of the items found there are also in this presentation. So who was Hugo Leuteritz? Well, he was the genius behind Pan Am radio communications from 1927 through at least 1946. He was born in 1897 in Brooklyn. He was a self-described amateur radio man in 1911 at age 13. He said he mostly listened, but later he did have a spark transmitter. We have looked at all the early call books, and we have not been able to find a call for Hugo Leuteritz. From 1916 through 1918, Leuteritz worked at the U.S. Navy in a civilian position called Junior Radio Expert Age, and it was a radio engineering position. Here's a very interesting photo that came from the Leuteritz archive. It's taken at the Brooklyn Navy Yard, New York, 1917. A number of gentlemen are working on a parade float for a victory bond drive that was going to be happening shortly. And Hugo Leuteritz is front and center in the picture. Thanks to Robert Lozier and Jim Cruiser, we were able to sort out what all was on this slide. The float theme is technical progress. To the right of Hugo Leuteritz is a whole complete setup of early Marconi radio pieces that we think came off of the USS Solace, which is a hospital ship based in New York, probably during a wireless upgrade. To the left of Hugo Leuteritz is a power supply switching charging panel, and on the far left is a new 10 kilowatt quenched gap spark transmitter made in-house at the machinery shop of the Navy Yard, New York. So we think this equipment was destined for the USS Solace, but it was used in the parade as the new equipment. Leuteritz went to work at RCA in the engineering department in February 1919. RCA was formed when GE and Westinghouse took over assets of American Marconi. He first worked at an old farmhouse laboratory in Riverhead, New York, which was near the site later known as Rocky Point. He worked with very famous folks such as H.H. Beveridge. He was responsible for static research. He also met David Sarnoff, while David was still a radio operator in Nantucket. Here's a internal employee newsletter dated January 1921. And the comment says, "One thing that puzzles us is why Leuteritz goes around firing a toy rifle into the air. Surely he can't expect to kill static that way." So what better place to work to learn about static is down in Florida and the Caribbean, which is where Pan Am Airways started, flying between Key West and Havana and back. Hugo thought that the time was right for RCA to come out with some lightweight, purpose-built aviation radios and use them for communication, but also navigation using a loop antenna like ships. Now, RCA was not ready to commit to that. Here is some pictures from the 1927 RCA Pan Am aircraft test. And in the picture, on the bulkhead, is what I think RCA aircraft receiver AR-1308. Also hanging in the back from a frame from bungee straps is a RCA 10-watt transmitter. So they were testing AM versus CW. They also used various transmitters to test various power levels. They were also trying to determine which frequencies propagated best through the static. Here's a picture of the 100-watt transmitter. And you can see they also experimented with wind generators to help power the transmitters. Now, Hugo Leuteritz was still working for RCA when, on 15 August 1928, Pan Am lost their first aircraft and, unfortunately, their first passenger. They took off from Havana, Cuba, and they were bound for Key West. The weather turned ugly, the winds changed direction, and they ended up out in the middle of the Gulf of Mexico, and eventually they ran out of gas. So they tried to do a water landing beside a tanker. The aircraft flipped over. Unfortunately, one of the two passengers for that day drowned. The body was not found. Hugo Leuteritz helped to save the other one, and also he was somewhat injured during that rescue. Now, so they were on a 90-mile flight, and they ended up 300 miles off course. So while Hugo was recuperating, he started working on radio direction finding equipment. There at Key West, he came up with his own loop antenna, and he used radio 28 receivers on the ground. He also used those in the air during some of the his initial testing. Eventually, Pan Am was able to woo Hugo over as a communications engineer. Here's the earliest picture we have of Hugo Leuteritz and some Pan Am radios. This is circa 1928. We see the same picture in this national parts ad, famous equipment using national parts. And much of the equipment built by Leuteritz and team has that national look, using national dials and other connectors. And though Leuteritz was an RCA man, he liked national parts, and he liked building radios. Now, Pan Am had a subsidiary called PAMSCO, Pan American Manufacturing and Supply Corporation. They were based in Coral Gables. Basically, everything that Pan Am bought for their worldwide company was purchased through PAMSCO, and if anything needed to be remanufactured, repackaged, packed for shipping, etc., it would be done at PAMSCO. So this is where the radio equipment that Pan Am used during the early years was either manufactured from scratch, or highly modified. Originally, Leuteritz was over this, but later, Ferris W. Sullinger, who actually came from GE, headed up PAMSCO. Juan Trippe had been a Navy aviator towards the end of World War I. He was the head of Pan Am Airways. He wanted Pan Am to be America's premier airline and their only international airline. He, because of his Navy upbringing, he used many of the terms. Instead of aircraft, he talked about clipper ships. Instead of takeoffs, he talked about sailing orders and casting off. He was also big on uniforms and for example, the crews marching out in cadence to the aircraft to help entertain the passengers. Now, in the early days, to be successful, an aviation company had to have some mail contracts. If they didn't have the mail contracts, they really couldn't get started with enough passengers and merchandise to make money. So Pan Am fought for every mail contract they could. Charles Lindbergh, of course, was the most famous name in aviation, having been first to fly the Atlantic. He was also very wealthy because of the book about that flight that was published. He wanted to fly more. He wanted to fly survey flights. And so he signed on as Pan Am's technical consultant and a stockholder and worked with Pan Am for some 40 years. Pan Am used Lindbergh as the front man for goodwill flights and any type of public appearance and event. Also, the first flight on typical a new mail route. Lindbergh wanted to fly survey flights. In other words, flying from Miami to various places in the world, figuring out the best paths for future Pan Am flights. Lindbergh was quite the evangelist. Here he is quoted as saying that ocean airlines are coming next. Lindbergh and Juan Trippe pushed hard on the aircraft manufacturers of the day to get them to keep building bigger planes, planes with better endurance, better lift, bigger engines, and one of those was Hugo Sikorsky. And here Lindbergh is with Igor. Andre Priester was the chief engineer at Pan Am and the number 2 man. He also worked with Lindbergh and Trippe, trying to encourage plane manufacturers to make a plane that could carry a number of passengers and freight 3,000 miles so they could use it to fly the Pacific and also Europe. Here's a list of some of the early aircraft that Pan Am used. They started off with land planes. Then the Sikorsky S-38 was actually a hybrid. It was an amphibian with wheels. And then from the Sikorsky S-40 on, they were true amphibians. Also the Consolidated Commodore, which was an early version of the PBY. Also the Martin M130, which was the first long-distance aircraft that could carry passengers, make money. And then the very large Boeing 314. Also, then they also started using, later on, land planes again, DC-2 and DC-3. Charles Lindbergh and his wife Anne flew very extensive survey flights for Pan Am in 1931 and 1933. Anne Lindbergh was a licensed pilot, and she could navigate, but she also was the radio operator for the 1933 survey flights. And of course, Charles being a Pan Am employee, they used Pan Am, standard Pan Am radios for that flight. Also, Hugo Leuteritz was the one that trained Ann and Charles Lindbergh, got them ready so they could pass their third-class radio telegraph license. He gave them 2 months of training. He helped them get their Morse code up to 17 words a minute. He also taught them electronics theory, how to troubleshoot and fix Pan Am radios, and how to communicate with ships and shore stations. Here's a video about their survey flights.
Celebrity aviator Charles Lindbergh and his wife Anne took seaplanes on some of their legendary flights to chart new airline routes. Landing on water made it possible for them to explore some of the remotest areas of the globe.
Into the cockpit of his Lockheed Sirius climbs Colonel Charles Lindbergh. Mrs. Lindbergh is with him. Flying together, as always, they are heading from Washington, D.C., across the Bering Sea to Japan. A perfect landing after almost half the world has rolled by beneath their wings. Cheers and waving flags as Tokyo greets them. Colonel and Mrs. Lindbergh are starting on another and perhaps their greatest journey. A 29,000-mile survey flight from New York to Labrador, Greenland, Iceland, Europe, the Azores, Africa, Brazil, and return to New York.
During the late 1920s and 1930s, as a result of the early radio tests Leuteritz and Pan Am did, they stuck with CW and went all CW. They had tried AM, but those transmitters were too heavy. They turned out being too unreliable, and they offered poor range through the static. A CW-only transmitter went much farther through the static of the tropics. Also, Pan Am, because their planes were larger than most, they were the first airline with dedicated flight radio operators, or FROs. Now, the flight radio operator was the best in the business. Typically, they had come from the Merchant Marine. They had at least a second-class radio telegraph license with an aircraft endorsement before they could fly. Some of the best documentation in the Leuteritz archive is our list of equipment projects performed or accomplished by Pan Am under Leuteritz's tutelage. We're going to talk about the receiver and the product lines of Pan Am. Here's back to that picture we saw earlier. That was a picture of the Model A receiver. Leuteritz says actually came out in 1929, a regenerative receiver using number 12 and number 2 tubes with transformer audio. And then later that year, Model B receiver looked very similar. It had resistance coupled audio instead of the transformers. At the History Miami Museum, there is an example of the Model C receiver, also 1929 time frame. It's basically the same as the A and B models, except some physical differences. In this case, it's unpainted. And if you zoom in on this data tag on this receiver, you see it says Model C, serial number 1. The best preserved radios that the Lindberghs used are in the National Air and Space Museum. And of course, these were manufactured by Pan Am and used by Ann Lindbergh on the survey flights. Here, Leuteritz says in 1932, they came up with the Model ACB receiver, which is the Lindbergh receiver. It's still a regenerative receiver. It's using slightly different tubes. And it's the same as the next model, except for some physical details. So you can see the data tag there as well. Here's a picture of the inside of the Model ACB, a 4-tube set with plug-in coils and coil storage. In 1932, Pan Am came out with their Model ACC receiver, which is pretty much the same as ACB, except it was shaped a little different. And then in 1935, they came out with an improved ACC called the ACF. And here's a picture of a Model ACC or an ACF receiver in a Sikorsky S-42. Now, Hugo Leuteritz, this is a quote from his archives. My contention was that Pan Am Airways needed radio communications and navigation, and that the navigation calculations should be done or aided from the ground. In other words, there's more resources available on the ground, more people than up in the plane, where at best you had one flight radio operator. Now, the way direction finding was done in the old days is that a plane would hold down the key or send long dashes to keep from burning out the transmitter or the dynamotor, and the ground took a bearing and tuned for minimum, and then reported that bearing up by radio back up to the plane. Here's a video. In the early days, planes could not fly above the weather or above all weather. If they ran into bad weather, the only option they had really was to fly around it. So here's a very early Pan Am video talking about a plane that needs to fly around some bad weather, and it shows the direction finding team on the ground providing new bearings for the pilot.
The weather ahead looks pretty tough. Bear to the right of that storm. They're on the right, sir. And 12 for a bearing.
New radio direction finders have been developed with a range of 2,000 miles to guide the Trans-Pacific Express from base to base.
And a plane changing course, 5 degrees north, kind of heavy weather thunderstorm. He's bearing about 272. Okay, tell him we'll give him bearings every 15 minutes.
Now, in that video, we actually saw 5 people on the ground working together to provide the plane with new bearings. We also saw Pan Am's Model DFL rotating loop, which Leuteritz came up with in 1932. This was their original direction finder system for airport use. The control down in this picture went up through a mast up the side of the building, and at the top of the mast was a diamond-shaped loop. Pan Am continued to use this system at all their locations across the Pacific, even when they, after they started building their next generation direction finding equipment, which was the Adcock system. And you can see one of the towers for the new Adcock system behind this direction finding building. And this is in Manila. Here's an inside picture of that direction finding building. We see some radios we haven't talked about yet. And here's another picture, and this is in the Philippines. And we see that bigger receiver, and we also see a couple of radios that look like SW3s. Now, Pan Am was only in Macau for about a year, from 1935 to 36. Originally, they wanted to fly to Hong Kong, but the British weren't ready to compete with Pan Am, so they didn't give them landing rights. So Pan Am set up their base about 30 miles away in Macau. And this is a picture of the direction finding building they had up on top of a mountain and it's still using the same diamond-shaped loop. If you look very closely, you can also see there's a spider dipole, cut for 3 different frequencies there, used by Pan Am at this site. Inside that direction-finding building, here's the original loop type equipment. Now, there were some limitations of a loop system. They were subject to night effect or skip, which increased at night. And actually limited to use over comparatively short distances. Worked better close in than way far out. The new Adcock system that came next would give a much more accurate bearing over distances well over 1,000 miles, and was practically immune to the night effect errors. Here's a patent with the name F.W. Sullinger on it, and it shows a 4-wire, basically 2 inverted V's feeding a goniometer down on the ground. And also the bottom image shows a rotating pair of vertical dipoles. Here's the earliest picture we have of the Adcock style antenna that Pan Am went with next. This is at Miami. Here's a close-up of that picture showing 4 radio towers, each holding up a wire that goes down to the direction-finding building in the center, where the goniometer would be and the radio equipment. The next version of antennas and towers used by Pan Am were vertical dipoles mounted on poles. Here's the patent for that over on the left. You see the 2 vertical dipoles adjustable in the middle and rigidly mounted to a post. Now, the next generation of that was the vertical dipoles being held up on a H-shaped wooden tower, and it would be more adjustable left and right. And also, they could still make any adjustments in that center piece between the 2 vertical dipoles with poles from the ground. So this evolved into Pan Am's dual Adcock as of 1934. This was the airport direction finder system. It was actually a dual Adcock. It took 4 towers to hold up 4 wires for an Adcock. But in this case, Pan Am has 8 towers here, so they actually have two different Adcocks at each site. Here's a picture of Alameda, 1935. You can see the dual Adcock towers in the background and the China Clipper in the foreground. Here's a picture on Wake Island, and you see a little more detail of the wooden towers, which were painted red and white and made out of redwood. So the dual Adcock had an outer and inner system. Each of these systems had 4 vertical dipole antennas, and they fed a goniometer down on the ground. Since the antennas were fixed, you needed something to turn so that you could figure out the direction of the incoming signal. Now, this article says that the Adcock system covered any frequency from 5 to 8 megacycles. And by the way, over on the left, I try to keep track of all the references to Pan Am frequencies, and here's some of these that I've come across so far. Now, in the photo album, if you look real close, you can see 4 pictures of the outer system, and it says they're oriented north, south, east, or west. Also, one of the pictures shows one of the towers of the inner system. And it says these were set up northeast, northwest, southeast, southwest. And of course, the inner system towers were closer in than the outer. Here's another description of the dual adcock. It says the spacing between the antennas of one set is approximately 200 feet, and that's the outer system. And between the other set is approximately 80 feet, which is the inner. Says the outer was used frequencies 200 kc up to 2 megacycles, and the inner system from 2 megacycles to 6 megacycles. And again, the antennas are vertical dipoles. They're fixed, made out of brass rod. They're about 18 feet long in total. They're held up by towers, which are basically 25 feet tall. And there's an adjustment in the center of the vertical dipoles. So here's engineer Bill Taylor up on top, checking the calibration of one of the new towers that they're putting up here. Here's another picture of the Adcock inner system, freshly built there in Manila. You can see the direction finding shack in the center. And over to the left, another picture of the oscillator and receiver used for initial calibration of the Guam direction finding system. Here's a very rare picture of the actual direction finding receivers used by Pan Am. You can see a goniometer to the left of each of the receivers. There's plug-in coils for the receiver up on the wall. Here's another picture. So they had two antenna systems, two Adcock systems, and so they had two receivers, two goniometers. So both systems could be used at the same time, if need be. Now, in the notes, Leuteritz talks about direction finding, and that's my comment up there. It says 1 degree of latitude or longitude, roughly equal to 60 nautical miles, or 69 land miles, if you will. He says, Leuteritz says at a distance from 0 to 600 miles, the accuracy was 1/2 of 1 degree. And then from 600 to 1800 miles out, about 1.5 degrees. And if you have one station over 2,400 miles, you could get within 1.5 degrees with one station. But if two stations work together, you could get it down to 1/2 degree, which would be roughly 35 miles. Here's a video showing the China Clipper and most of the Pan Am Pacific bases.
The Pacific has the world's widest collection of wind, rough water, and weather. Everyone always complains about the weather. Well, PAA can't change it, but we sure can't tell you what it's going to be. Before we're through, there won't be a place on this planet where we haven't plotted the storms, mapped the sky winds, charted sunrise and moonset, and taken the little old temperature.
Here in Alameda, California, by the shore of the Pacific, 7 men in a Martin 130 are scheduled to make the longest overwater flight ever dreamed of by any airline. And what a crew! 5 of the 7 are transport pilots, 3 are registered aeronautical engineers, 2 are master mariners, 2 others have navigation papers. Their training will give you some idea of the preparation behind America's conquest of an ocean.
China Clipper, Captain Music, stand by for station reports.
San Francisco calling. Come in, all stations. PAA Ocean Air Base number 1, Honolulu, Hawaii. Standing by for orders. PAA Mid-Ocean Air Base number 2, Midway Island, standing by for orders. PAA Trans-Pacific Air Base number 3, Wake Island, standing by for orders. PAA Mid-Ocean Air Base number 4, Guam, standing by for orders. PAA Trans-Pacific Air Terminal, Manila, Commonwealth of the Philippines. Ready and standing by, sir.
China
clipper. You have your sailing orders. Cast off and depart.
13 flyers have lost their lives trying to wing the 2,400 miles from California to Honolulu.
Here's another national parts ad. I took the liberty of changing it slightly. Instead of saying what is inside a clipper, I asked what radios are inside a clipper. And that was one of the challenges of putting together this presentation. There was very little known of the various models of Pan Am radios. Here's a picture, April 1936, Fortune magazine, inside a Martin M130, which was the same plane you just saw a second ago. And here we have two radios side by side. They look like SW3s in a way because they have a national dial. In fact, they have two national dials each on it. But we didn't know the name of that radio. Here's the much larger Boeing 314 that came, the next plane. And you can see the FRO there. Here's a closer picture of the radio operator's station. Here's some commentary about the two receivers there. It says the airplane carried two identical receivers built by PAMSCO, Pan Am subsidiary, tuned RF units with regenerative detectors, plug-in coils, two stages of resistance coupled audio, frequency range from 200 kc up to 16.5 megacycles. And they were powered by batteries while in flight. We finally figured out the name of these because one of them is in the Leuteritz archive in a box. It's the Pan Am Model ATM receiver. Besides the one up at Neum, we've located one additional unit, which is down in the Dominican Republic. So two total so far. It was designed in 1934. And again, it says it's a regenerative set using 36 and 37 tubes, and the size decreased over previous models. What I find so intriguing is that basically some of the largest aircraft in the world had on board some of the smallest radios available, and that was a Leuteritz thing. Here's the data tag of a Model ATM. You can see 7.5 pounds. Here's an inside picture, 4-tube radio, plug-in coil, and some coil storage there. There's a logging dial, top left of the receiver. And inside there's a calibration chart for that radio. Here you see 6 of the 7 coils in the coil storage. Of course, these coils were hermetically sealed to keep out moisture so that the weather wouldn't affect them. In these last few pictures, we also saw a single dial variant receiver, and I do not have any information about that receiver yet. But in this picture, the FRO is he at least has a Fiberclex bug there, should he be able to use it while in flight, and also 2 McElroy straight keys. Now, the next step was for airplanes to have their own direction finding system. And Pan Am started working on this around 1932. This is an S-42. If you look very closely in the picture, there's a pole that comes out above the cockpit that actually leans backwards a bit. And from that pole were 2 inverted V's, 4 wires, fixed antennas that were used for direction finding. Wilson Jarboe was the most famous early flight radio operator. Here's his comments. It says the first airborne direction finding was on S-42, 1933, built by Bolini Tulsi. It says Solinger of Pamsco, who was H.C. Leuteritz's brother-in-law, he made various evaluation tests of the Bendix RCA and Lear radio direction finding systems of the time. Now, the China Clipper that you just saw flying in the previous video, instead of having a pole that leaned backwards over the cockpit, they actually have one that's leaning forward, and that was their standard setup for the fixed antennas direction finding equipment. And you'd have the 4 wires hanging off of that forward-leaning post. Inside the plane, from 1934 on, Leuteritz came up with a goniometer to work with the fixed, he calls them fixed loops, the fixed antennas on the front of the plane. And in 1935, they designed in-house an RF amplifier, model ARA, that was used ahead of one of the receivers for direction finding reception and turned off when the plane wasn't doing direction finding. Here's another write-up that says basically just that. 2 fixed frame inverted V loop antennas, and then goniometer there for the radio operator, RF amplifier he could turn on and off, and this is the way he got the direction finding bearing information since the antennas were fixed and could not rotate. Now later, 1939 time frame, Pan Am went back to the traditional loop antenna, manually tunable or turnable. And here's a picture of an FRO doing just that. And you can still see the model ATM receivers in the background. So here's a video that shows this in action.
While the passengers slept, the ever-vigilant Pan Am flight crew worked throughout the night. Weather reports were constantly relayed to the flight crew from island bases and ships at sea. Airspeed, fuel consumption, and existing headwinds were regularly checked to determine flight times, positions, and estimated times of arrival. Contact on a predetermined schedule with both Treasure Island, Matson Liners, and Hawaii was maintained by the radio operator on this leg of the flight. He continually relayed weather changes to the flight crew. The flight engineer constantly monitored the engine gauges and, when necessary, uses a catwalk inside of each wing to check individual engine performance. Minor maintenance could be performed on any engine from inside the wing. Continually checking his position, the navigator monitored the route to Hawaii to be sure they were on course. He used, when necessary, celestial navigation to accurately get position fixes. Pan Am pioneered radio navigation and used it extensively to assist navigators in plotting positions and confirming direction headings throughout the Pacific. Without it, locating a small island in the Pacific would almost be an impossible task. It was one of their secrets to success. Pan Am left nothing to chance. Passenger safety was its #1 priority.
Here's a picture of a DC-3, circa 1939 or 40. There's still 2 Pan Am ATM receivers on board, and you can see the FRO turning manually turning the loop that's part of the direction finding system above his head. Now, another radio that we found in the archive at New England Air Museum was this radio. It's Leuteritz says it was designed in 1941, and it was the model CDP receiver. It's a superhet with band switching. It's capable of manual and automatic direction finding. It could work with the now standard radio range radio signals. It was capable of phone and CW and had 8 crystal-controlled frequencies. And besides the one at NEOM, we found one more of these since then. It reminds me of the being a Swiss Army knife of radio with all the connections and all the capabilities of this radio. In fact, they don't call it a receiver, they call it receiver control. So let's talk about ground radios at Pan Am. Here's a very early picture of Pan Am's radio equipment, Habana, Cuba, 1931. In the picture, you can see 3 RCA AR 1496 receivers. Here's a picture of a AR 1496. Plug-in coils are sitting on the top, and you'll notice that it has 1 meter on the left and 3 main dials, and the data tag information is over toward the right. These were manufactured by GE and sold as RCA receivers. Very successful model, 4-tube shortwave receiver, and it was for the commercial market. And it used a screen grid tube and followed by a regenerative detector and 2 stages of transformer coupled audio. Very solid mechanical construction and shielding, and it was designed to be powered by batteries. And we think approximately 5 of these exist. Here's an inside picture. You can see the tuned RF over to the left, the detector in the center, and the 2 stages of audio to the right. Here's a quick picture of 2 of the plug-in coils. Now, thanks to our class N3FRQ, we're gonna show you a standard RCA 1496 receiver in action. First doing CW. Here's a quick video of the RCA 1496 on AM.
Proportions, so that the dictator could have the visual illusion it stretched to infinity as he was looking at it from the top story of the largest ego booster in history. And that happened was just the tip of the iceberg, if I were permitted the pun. One Romanian his obsession with crafting a new society. And a building of any historical value became suddenly part of a potentially endangered species due to its possible association with bourgeois values and society. The fall of the regime makes any pre-1947 building a treasure to be preserved and cared for like any piece of vintage furniture. Unfortunately and very sadly, that has not been the case in the years following the regime change in 1989. The years went by. Old buildings that had just been neglected by the communist regime literally fell into dilapidation, standing like empty shells that a chick had begged its way out of. They stand as a sad reminder of an open and festering the government has yet managed to heal. Most of these buildings were appropriated by the Communist Party. It's locked up in evicted. Many of them lost their own.
Now, though single sideband signals weren't in common use back in the 30s, the 1496 does a pretty decent job.
What's your call, Jackie? Okay, good. I was listening for a while and I couldn't resist that subject. Yeah, we jumped.
So, personally, I think the RCA AR-1496 receiver should be famous, but it isn't. I like to call it the R390 of its day. It was used with all the big expeditions of the day. It was used by the Army, Navy, and Coast Guard. It was used on ships, ship to shore, and military and commercial, long haul. Here's a nice OTB article saying it's the first modern commercial shortwave receiver. Here's a picture of a 1496 being used on Byrd's first Antarctic expedition, 1928. Here's an article entitled The Coast Guard's Best Shortwave Receiver. And here's a very interesting picture of the radio center in the Philippines. And it looks like they have quite an involved automatic system of receiving CW and punching tape. But over to the left, there's something that says Standby GE. And if you look, here we have an RCA 1496 receiver on standby. Now, in the photo album, there's many pictures that say 1497 receivers. These happen to be in the Philippines. It's pretty late. It's actually October 15th, 1941, and you see the batteries down on the floor. Now, what you're seeing there is actually the Pan Am airport receiver, and the only known examples at the History Miami Museum. Here's the wording of the insert. It basically says that they were modified by Pan Am, and they were used at radio stations across the Atlantic and Pacific. And it says that they were used until 1937 or 38. Well, we've just seen a picture where they're still in use right before Pearl Harbor. Now here's a comparison picture. On the top we have a Model 1496, and on the bottom we have the Pan Am airport receiver. And you can see the differences and the similarities. Leuteritz says, as of 1929, that Pan Am re-engineered this receiver to eliminate difficulties experienced with audio transformers, chokes, etc. And they also changed the layout of the receiver a bit. Here we are zooming into this was a special Pan Am airport receiver on display in one of the pictures. The top data tag says, Overhaul and Conversion by Pan American Airways, October 1930. The bottom, original data tag, says Radio Receiver Model RS-1, Navy Department, General Electric Company. So basically, apparently there was more than one variant of the RCA AR-1496, and Pan Am purchased and modified both types of receivers, possibly more different types of receivers, to re-engineer into their standard Pan Am airport receiver. So I'm looking for information on the GE RS-1 receiver. Now, at the New England Air Museum, there's a big stack of Pan Am schematics, and there's more than a handful of these schematics. detail exactly what changes were made to the 1496 to turn it into the Pan Am airport receiver. What other receivers did Pan Am use on the ground? Well, here's a picture of one. It's the RCA AR-60, fairly expensive receiver. Most of these went to the Navy, the Army, the Coast Guard, and Pan Am worldwide. They came in two colors, black and a silver front. Here's a picture of a black rack mount receiver. Has two main tuning dials. One's for megacycles, one's for kilocycles. No S meter, but a very nice receiver, very stable. Here's three of the movers and shakers associated with the Antique Wireless Museum, gently rubbing the museum's nice AR-60 silver front. Here's a Manila picture showing a lot of receivers, including a RCA AR-60 and three of the Pan Am airport receivers and plug-in coils and a lot of other good things. Here's a quick video of, and if you look real quick, you'll see the radio operator on the ground that's sending the Morse code. He has an AR-60 behind him.
3 p.m., November 22nd, 1935. The China Clipper rose from San Francisco. First trans-Pacific through schedule to the Orient. The first airline in the world to span an ocean. From Pan American's own radio stations, which later did war service, her crew learned the weather and kept their course through the clouded night.
Here's a picture dated January 21, 1939, and it shows three AR-60 receivers. The one on the right is a silver front desktop unit, and the two over on the left are black rack mount units. This was a radio facility in New York that supported flights going across the Atlantic, and here they're trying to help out British Imperial Airways. One of their planes had mechanical problems and had to sit down on the water. It was also an amphibian, and the British asked if the Pan Am folks could try to contact it while it was there, and they were unable to do that, but the plane was rescued shortly thereafter. Here's a radio news cover from August 1940. It shows one of the earlier flight radio operators, Tom Roberts, and he's operating an AR-60 with his right hand, sending Morse with the other. You can see an airport receiver there with him as well. And here's a picture of probably the most famous Pan Am flight radio operator, Wilson Jarboe. They called him Turner, and he's also got a nice RCA AR-60 receiver. And over to the right, is that an SW3? Well, in fact, it is. The Pan Am used a lot of SW3s. They also modified them to some extent. They added an on-off switch in the front left corner, a headphone jack in the front right corner. They added a logging scale on the front of the radio. They also have a data tag up on top of that lid that I don't have a picture for. Now, I haven't come across any schematics talking about what other mods were done, but there is no known example. So if anybody knows of a Pan Am Airways SW3, I'd love to see pictures and talk to the folks. Here's an SW3 modified that's in use in Manila, and you can see some of the coils there mounted on the wall. Here's a smaller facility, also in the Philippines. And if you look closely, you can see the SW3 over to the right and a smaller, approximately 10-watt transmitter over on the left. Here's a picture of Guam, circa 1935, and you see a Pan Am SW3 front and center in the picture. And here we are back at Macau in 1936. This particular shot shows 2 SW3s there in use. Here's a couple of inside pictures of that round Macau direction finding building. You can see the direction finding equipment over on the left and an SW3. And over toward the right, you also see another SW3. Now later on, Pan Am started using national moving coil receivers, especially in their operations centers. And here's one such one. If you look very closely, the 3 folks that are sitting along the wall, each of them has 2 national receivers at their station. When World War II started, Pan Am expanded into Africa so they could fly supplies in support of the North Africa campaign. And here's pictures of a Pan Am facility in Liberia, Africa, and you can see national moving coil receiver over on the right in Iraq, and also another one over on the table to the left. Here's a receiver. Provenance says it was actually used by Pan Am operations in Brownville, Texas, which was responsible for Mexico and the Caribbean. And it's also a national moving coil receiver. Here's the copy of the manual. It says this receiver was made specifically for Pan Am Airways. Here's the inside picture in the it's an NC240 receiver, but it has an external power unit, which is the first I've seen like this. So it has a big dog house supply capable of 110 and 220 volts from 40 cycles on up. So a very big supply, very unique. So we've talked about the Pan Am receivers. Let's talk about the transmitters, which were developed in-house as well, based on the Leuteritz notes. Here's the first Pan Am made aircraft transmitter. This particular one was donated to the Smithsonian by Juan Tripp. Here's a slightly better picture that was found in the Leuteritz archive, a PAMSCO picture. And you can see the tube and the big coil sitting on top of the dynamotor. Now, Leuteritz says that Pan Am had a Model B telegraph transmitter, and this was circa 1928 or 9, open-type transmitter, 10-watt CW, single channel. The next model, which they used very widely, was the Model 10C in a number of different variants, and because this transmitter evolved over time. It started off as a 10 or 12 watt single channel CW transmitter. Then they added some output loading in the next model. Then they upped the power out to 25 watts and made some other improvements. So this transmitter was used widely and continually evolved. And this was the Lindbergh transmitter. So this is the one that Ann Lindbergh used on their survey flights. And here's a copy of the Lindbergh's aircraft radio station license. And if you look over to the right, it says that the transmitter being used is a PAA Model 10C. And over to the left, it shows 6 different frequency ranges that used for the transmitter. Of course, it had big plug-in coils. It was a Morse code only, and it put out 12 watts. So, and they talked around the world, back to Miami with this set, by the way. And here's a picture of Ann's Morse code key, a couple of the larger transmitting plug-in coils, her headphones. Here's another one of this type of transmitter in a consolidated Commodore aircraft. And it also shows the Pan Am antenna reel, which also evolved from 1930 up through 1940, different models. One of the unique radios that the Lindberghs carried on their survey flights is this crash-proof, waterproof telegraph transmitter receiver that Leuteritz came up with in 1930. It was for emergency use. It was completely self-contained and very well made. If you zoom in on the data tag of this transceiver, if you will, it says it's serial number 1. So I'm not sure how many of these were made. This one's in the Air and Space Museum in Virginia. Now, also, here's a later transmitter that has shown up. It's the model 75AX2, 2 crystal controlled channels, 75 watts out. Here's another slightly later version of aircraft transmitter. This is, it says 12 channel or 24 frequencies and 75 watts out. This is the 75AX12. Here's a picture of another transmitter touted to be an airport transmitter, though it has the plane, the airplane type base on it, spring mount. So let's talk about ground transmitters. One transmitter that was used very widely across the Pan Am system was developed in-house, and it was the Pan Am Model 24 airport transmitter, and this was built in Miami, April 1929. There's Leuteritz over on the left and Sullinger over on the right, and a number of other folks. And this transmitter used a UV204 tube, a couple hundred watts out. Here's a picture of one installed in the Philippines. Here's another picture showing the Kohler generator that powered that transmitter. And also you can see the 2 lead-in wires up above the transmitter. Here's a side shot of the transmitter, and you can see it also had plug-in coils that you had to do. And also up where the antenna wires leaving the building, there's apparently some type of antenna switch there as well. Now, Pan Am also bought some transmitters from Western Electric, a big 14A transmitters, which came in 2 cabinets. One cabinet was the transmitter, one was the power supply and the AM modulator, and 400 watts, and it had 10 preset channels selectable by a telephone dial that you see in some of the pictures. And also it says in reserve is the PAMSCO transmitter there in the center. Here's another picture of the Western Electric 14A transmitters in place, and this is on Guam with the generator. Here's a picture of the 14A transmitter being installed. Notice those 2 ties there. Here's another picture from Haiti of the same PAMSCO transmitter. There's no known example of this transmitter at this point that I know of. Here's another picture. This is Wake Island, 1935, temporary radio station. You see the PAMSCO transmitter straight in front of the operator, and also a couple of airport receivers over on the right. Here's another picture from the Operations Center in Liberia, Africa. Over on the right, we also have the PAMSCO transmitter and a what looks like an antenna tuner of some sort over on the wall. And then over to the left, we have a National 100XA type of receiver, which was the next model national receivers after the moving coil line. Here's another Pan Am transmitter installed at one of the Pacific sites. It's similar to the PAMSCO transmitter that we've already seen, but I do not have any information about this particular transmitter at this time. Here's a much larger Pan Am transmitter, lower frequency transmitter, 800 watts, telegraph transmitter. This picture shows the transmitter, the power supply, and in this picture you can better see the antenna tuner that went with this system. Now, one that's not mentioned on Hugo's list of accomplishments is this little airport transmitter that's dated inside April 1937, a one-tube transmitter that showed up recently, and we think maybe it was a beacon transmitter of some sort. There's been two pieces of Pan Am test gear that has showed up. This first one was found by Rod Bloxham, K0DAS, at the Orlando Hamfest back in 2017. It's an artificial antenna. Another showed up on eBay. It was originally advertised as a Pan Am radio receiver, but it turns out it's a portable frequency standard, and unfortunately, it's missing the most important part, the Pan Am data tag. Now, in the photo album of the Pacific radios, there are these unidentified transmitters, and it's dated 1939. So my guess is these were some of the next generation transmitters that Pan Am had developed for possible use around the world, and possibly they never were manufactured in quantity because of World War II. Now, from the 1940s on, there was still some amphibians in use, but the newer planes that were being designed were land planes again, including the Douglas DC-4 and the pressurized Boeing 307 Stratoliner, which could fly above some of the bad weather. Not only was it the end of the amphibian era, World War II and post-World War II meant the end of homebrew aviation radios. So you start seeing standard radios in Pan Am cockpits. Here's one of the last FROs who was flying a first flight from New York to South Africa. And if you look, he's on this plane, which is a DC-4. There's a BC-348, and above it is the Collins ART-13 transmitter. So standard transmitters and receivers of World War II, which were very plentiful at that point. Plus, there's a lot of people that knew how to use those. Here's another picture of a pair of BC-348s in a DC-4. A Pan Am picture of a Collins ART-13 transmitter. They also apparently used a quantity of BC-375 transmitters. And these have very large tuning units that were needed in case a frequency change was needed. So they had to store them somewhere in the aircraft. And also there's a box of radio spares underneath the lavatory sink as well. Also, Pan Am planes at this point were using ARC-5 command sets, the liaison sets that were on every U.S. bomber during World War II. So you start seeing standard military or commercial avionics equipment on Pan Am planes, including a radio compass, a radar altimeter, and early Loran units. Another change that started happening in 1937 is it was thought to be useful that pilots could talk directly to the tower on final approach. And so Pan Am would use small little 16-watt transmitters, AM transmitters that were crystal controlled. And this talks about that. And here's a picture of a Western Electric 25A transmitter, pair of 6L6s, not much power. And here's a typical receiver that might be used in the cockpit in combination with that small AM transmitter. So when the war started, the fact that Pan Am Airways had set up sites all across the Pacific, all down across South America, very advantageous to the U.S. And it helped our military services come up to speed very quickly and start ferrying aircraft around the world. Now, in 1943, President Roosevelt rode on a clipper ship, if you will, to the Casablanca summit. And John Leslie, who was a VP in charge of this flight, he named the presidential aircraft Clipper One. Of course, this started an American tradition where the phrase Air Force One evolved from. Now, after World War II, in the late 40s, what we find is that pilots are doing all the talking. So the flight radio operators are out of a job by late 1940s. Here's a 1944 ERCO ad, Pan Am ad, talking about a ERCO radio receiver. And in the PAMSCO documentation, it has a number of pictures of this ERCO receiver. So it seems that this receiver was built at PAMSCO, and so possibly there was a connection between Pan Am and ERCO. Now, PAMSCO closed in 1946. Now, how about after that? Also in the Leuteritz archive was this flyer of products from Aerocom. And if you look at some of the naming conventions of these products, it sounds very much like Pan Am products. And on the other side of this brochure, here's a 100 AX-12 transmitter, aviation transmitter, that looks very, very similar to the earlier Pan Am produced 75 AX-12. And the naming convention is similar. So I think Leuteritz and Sullinger went to work at Aerocom, or possibly even started Aerocom after World War II. Here's a 1955 Aerocom ad with a nice collection of aircraft radio equipment and avionics. Now, Collins, avionics at that point in 1956 or so, Collins had a great relationship with all the armed forces, and everybody loved Collins gear, and the avionics division was the largest division, the most profitable division at Collins. So here's a little bit of discussion from the on the web circa 1956, where Hugo Leuteritz is talking to a Senate committee trying to keep or get Aerocom products as a second source to Collins radio equipment, avionics equipment. Here's a picture of Alice and Hugo Leuteritz circa 1976. So be sure to watch Across the Pacific, the early days of Pan Am, 3-part series. Stephen Lyons, the director, spent the last 10 years of his life focusing on this project, and he did really good. There's also another video here on the Antique Wireless Museum entitled The Radios and the Filming of Across the Pacific. And a handful of Antique Wireless guys got together and provided the best radios we could for the filming of the dramatic scenes of this series. One more source that's very interesting, the movie China Clipper was filmed in 1935 and released in 1936, and it was all about Pan Am And so it was filmed at Pan Am facilities around the world. So as you watch this movie, you will see quite a bit of Pan Am radios, receivers, and transmitters that we've talked about here so far. So thank you for supporting the Antique Wireless Association. If you have an interest in Pan Am radios or you know of some, love to see pictures, and feel free to contact me directly.